I am going to start a lecture series regarding clipper circuit. I will make total 5 videos. In my first video, I will talk about clipper circuit, construction of a clipper circuit, and I will show you the operation of a positive clipper circuit and negative clipper circuit. In my second video, I will talk about biased positive clipper circuit, and I will try to give you a clear idea how about every types of biased positive clipper circuit. After that, in my third lecture, I will talk about biased negative clipper circuit, and I will try to give you clarity of every types of biased negative clipper circuit. And in my fourth video, I will talk about combination or dual clipper circuit. And in my last video of this series, I will solve total 6 real life examples to show you how do we find the output voltage of clipper circuit, whatever the combination of the resistor and the diode of that circuit. So what is a clipper circuit? A clipper circuit is that circuit which is used to remove a certain portion of the applied waveform without distorting the remaining waveform of the applied input voltage. Let's say this is a block of clipper circuit, and I am applying a total sinusoidal voltage here with a positive peak of plus Vm and a negative peak of minus Vm. Depending on the configuration of the clipper circuit, I may get an output in which the entire positive half cycle will be eliminated or removed. In that case, I will get only the negative half cycle in the output side, or depending upon the configuration of the clipper circuit, I may get only the positive half cycle of the input voltage and the negative half cycle will be removed. Or the clipper circuit may not remove the entire positive half cycle, it may remove a specified amount of voltage from the positive half cycle and gives the total negative half cycle in the output side. Or there may occur this case when we get the full positive half cycle but a certain portion of the negative half cycle is removed. Or there may be another case in which a certain portion of positive half cycle and a certain portion of negative half cycle is totally removed. So depending upon the characteristics of the types of output, clipper circuits are classified into 4 types: positive clipper circuit, negative clipper circuit, biased clipper circuit, and combination clipper circuit. And a clipper circuit must contain at least one diode and a resistor. And if I want to remove a specific portion of a certain level of voltage from any applied waveform, then I may add a bias voltage in the circuit. Every clipper circuit will contain at least one diode. Therefore, it is very important to familiar you with the equivalent circuit of a diode. Let's say I have a diode here. This diode is D. A diode is in reverse bias when the negative terminal of the source is connected with the P side and the positive terminal of the source is connected with the N side of the diode. In that case, the diode is in reverse bias. So when a diode is in reverse bias, the equivalent circuit of a diode will be an open circuit. That means I can replace this diode with an open circuit when the diode is in reverse bias. And second condition is that when the positive terminal of the voltage source is connected with the P side and the negative terminal of the voltage source is connected with the N side of the diode, then this diode will be in forward bias. And when a diode is in forward bias, we can replace this diode with 3 equivalent circuit of this diode. First one is that when a diode is in forward bias, if I replace this diode with a short circuit, then this model will be known as ideal diode model. You may familiar with the built-in potential or the junction voltage of a diode. When a diode is in forward bias and if I replace this diode with its built-in potential or junction voltage, that model will be known as its simplified equivalent circuit. So if I replace this diode with its built-in potential, that means with a voltage source, with a DC voltage source built-in potential, the P side of the voltage source will be in the positive terminal of the voltage source will be in the P side of the diode, and the negative terminal of the voltage source will be in the inside of this diode, and we will replace this diode with its built-in potential. In that case, in case of silicon diode, we assume that this built-in potential is equal to 0.7 volt. Third equivalent circuit is that if this is a diode and it is in forward bias, I can replace this diode with its built-in potential and its forward resistance or dynamic resistance RF and its built-in potential. In that case, this model is known as approximate equivalent circuit. Okay, so when our diode will be in forward bias, I will replace that diode. If it is specifically told that this is an ideal diode, I will replace that diode with a short circuit, or if we are told that that is a silicon diode, I will replace this diode with a voltage source of 0.7 volt. Okay, now let me discuss the operation of different types of clipper circuit. Now I will talk about positive clipper circuit. What is a positive clipper circuit? Positive clipper will remove the positive half cycle of the applied alternating voltage. Positive clipper circuit is classified into two types: positive series clipper and positive shunt clipper. At first I will talk about positive series clipper circuit. This is the circuit arrangement of positive series clipper circuit. This is called positive clipper because this circuit will remove the positive half cycle of the applied waveform, and this is called series clipper circuit because see here we are taking the output across this terminal and this terminal. Across this terminal and this terminal we are taking the output voltage, and this diode is in series with the terminal across which we are taking the output. So this is a series clipper circuit. Now let me describe the operation of this clipper circuit. This is the applied sinusoidal waveform of this clipper circuit from 0 to T/2. That means during positive half cycle of the input voltage, this terminal will be positive and this terminal will be negative. Now see, the positive terminal is connected with the inside and the negative terminal is connected with the P side of the diode. That means this diode will be in reverse bias during the positive half cycle. So when a diode is in reverse bias, I can replace this diode with an open circuit. During the entire positive half cycle, our diode will be in reverse bias, so I have replaced the diode with an open circuit. As this circuit is an open circuit, therefore the current flow in this circuit will be equal to 0 because there is no current flow in an open circuit. As the current in this circuit is equal to 0, therefore this I will be equal to 0, or the current through this resistor is equal to 0. Therefore output voltage VO equal to I into this R. As I equal to 0, therefore during the entire positive half cycle our output voltage will be equal to 0 volt. During the negative half cycle, that means the interval between T/2 to T, this terminal will be negative and this terminal will be positive. See, as the positive terminal is connected with the P side of the diode and the negative terminal of the source is connected with the N side of the diode, that means this negative half cycle will drive the diode is in forward bias. So if I consider this diode as an ideal diode, I can replace this diode with a short circuit. See, I have replaced the diode with a short circuit and there will be a current flow in this circuit from this positive terminal towards this negative terminal. Therefore the output voltage will be equal to our input voltage, because see here we are applying the input voltage Vi during the negative half cycle and there is no voltage absorbing element in this circuit other than this resistor R. Therefore our output voltage will be equal to input voltage. That means our output voltage will change in the same way of our input voltage is changing. As the input voltage is going through negative half cycle, our output voltage will go through negative half cycle with a negative maximum value of minus Vm. See, this is the complete output voltage of this clipper circuit for this applied sinusoidal voltage, and in this output the positive half cycle of the applied voltage is entirely cut off or remove. Therefore this is known as positive clipper circuit. Now I will talk about positive shunt clipper circuit. As this is a positive clipper circuit, this circuit will also remove the positive half cycle. Why this is called shunt clipper circuit? See, here we are taking the output across this terminal and this terminal, and our diode is connected in parallel or shunt connection with the output terminal. So this is known as shunt clipper circuit, and we are applying this sinusoidal voltage at the input of this clipper circuit during the positive half cycle. That means from 0 to t by 2, this terminal will be positive and this terminal will be negative. That means this side of this diode will be connected with the positive terminal of the source, and this side of the diode will be connected with the negative terminal of the source. So when the input goes through its positive half cycle, this diode will be in forward bias. So when a diode is in forward bias, I can replace that diode with a short circuit. So if I replace our diode with a short circuit, our circuit will look like this. Okay, so this is, now see, during the positive half cycle we are taking the output across a total short circuit, and a short circuit has a resistance of R equal to 0. So whatever the current flow in this circuit, our voltage drop across this short circuit will be equal to 0. That means during enter positive half cycle there will be no output voltage. Now consider the negative half cycle of the applied input voltage. That means the voltage from t by 2 to t. Within this interval, this terminal will be negative and this terminal will be positive. Okay, this terminal will be negative and this terminal will be positive. That means the negative terminal of the source is connected with the p side, and the positive terminal of the diode is connected with the n side of the diode. That means this diode will be in reverse bias. So when a diode is in reverse bias, I can replace that diode with an open circuit. So if I replace our diode with an open circuit, our circuit will look like this. So in this circuit, as this is an open circuit, the current through this path will be equal to 0. As there is no current flow in this circuit, therefore the IR drop through this resistor IR will be equal to 0. That means there is no voltage drop. There is no voltage drop across this resistor R. So the output voltage will be exactly equal to our applied input voltage. During this interval, the input is going through negative half cycle, so do our output will go through negative half cycle with a negative maximum of minus Vm. Now let me talk about negative clipper circuit. Negative clipper circuit will remove the negative half cycle of the applied input waveform. Negative clipper circuit is classified into two types: negative series clipper and negative shunt clipper. So at first I will talk about negative series clipper circuit. See, this is the structure of negative series clipper circuit. The diode is in series with the output terminal across which we are taking the output. So this is a series clipper. I am applying this sinusoidal voltage at the input side of this clipper circuit, and I am taking the output across this terminal and this terminal during the positive half cycle. That means from 0 to t by 2. During 0 to t by 2, within this interval, this terminal will be positive and this terminal will be negative. See, the positive terminal is connected with the p side and the negative terminal of the source is connected with the n side of the diode. That means this diode is in forward bias, and when a diode is in forward bias, I can replace this diode with a short circuit. See, I have replaced the diode with a short circuit. So when I replace the diode with a short circuit, the output voltage will be equal to our input voltage. See, here we are applying the input voltage across this resistor R, and we are taking the output across this resistor. So this applied input voltage will be dropped across this resistor because there is no other voltage absorbing element in this circuit. So output voltage will change in the same way as the input voltage is changing. From 0 to t by 2 interval, the input voltage is going through positive half cycle with a positive maximum of plus Vm. So we will get an output of this shape during the positive half cycle with a positive maximum plus Vm. During the negative half cycle, that means from t by 2 to t, within this interval this terminal will be negative and this terminal will be positive. See, the negative terminal is connected with the p side of the diode and the positive terminal is connected with the n side of the diode. So this diode will be in reverse bias. So when a diode is in reverse bias, I can replace this diode with an open circuit. When I replace this diode with an open circuit, our circuit will look like this. As this circuit gets opened, so the current in this circuit will be equal to 0. As there is no current flow in this open circuit, the voltage drop across this resistor equal to IR, and that will be our output voltage. As the current is equal to 0, our output voltage will be equal to 0 during the entire negative half cycle. That means from t by 2 to t, within this interval our output voltage will be equal to 0 volt. So this is the complete output voltage of the negative series clipper circuit. And here see, in the output there is no negative half cycle which we applied in the input side. That means the negative half cycle is entirely removed. So this is called negative clipper circuit. And this is the last one, negative shunt clipper. This is called negative clipper because this circuit will remove the negative half cycle of the applied voltage, and this is called shunt clipper because the diode is in parallel with the output terminal. So during the positive half cycle of the applied input voltage, that means from 0 to t by 2, from 0 to t by 2, this terminal will be positive and this terminal will be negative. Okay, so see, the positive terminal is connected with the inside of the diode and the negative terminal is connected with the p side of the diode. That means this diode is in reverse bias. So when a diode is in reverse bias, I can replace this diode with an open circuit. So this is our open circuit. When this circuit gets opened, therefore the current in the circuit I will be equal to 0. So as the current is equal to 0, therefore there is no voltage drop across this resistor R, because I into R equal to 0. As there is no voltage drop across this resistor, so the input voltage will be appear directly across the output terminal. So our output voltage will be equal to input voltage, and during the positive half cycle the input is going through positive half cycle, as the output voltage is changing in the same way as our input. So our output voltage will take a shape looks like this, with a positive maximum of Vm. Okay, during the negative half cycle, that means t by 2 to t, this terminal will be negative and this terminal will be positive. So the positive terminal of the source is connected with the p side and the negative terminal of the source is connected with the inside of the diode. So this diode is in forward bias. As this is an ideal diode, I can replace this diode with a short circuit. So if I replace the diode with a short circuit, our circuit will look like this circuit. And see, we are taking the output across a short circuit, as the voltage drop in a short circuit is equal to 0. So during the negative half cycle, our output voltage will be equal to 0. And this is the complete output voltage wave shape for this negative shunt clipper circuit. Okay, that's it. Thank you.